Hello, this is Ryan from High Desert Math Tutor, and today I want to talk to you about how to evaluate trig functions that come as a combination of trig functions with inverse trig functions. So just to begin, I want to do a quick review of what an inverse trig function is. So inverse trig functions are angles. So in this instance, we can say theta, the angle theta, is the same as cosine inverse of -2/3. If we say that, we can rewrite this problem here as cotangent of cosine inverse -2/3 is the same as cotangent theta. Now, we need to draw a triangle to understand what angle would make cosine -2/3. To do that, we can really draw this with any sort of perspective, but I'll throw this on a set of coordinate axes. We have x, we have y, and if we go back to SOHCAHTOA, this will tell us sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for us, we are interested in cosine. So cosine theta is adjacent over hypotenuse. And for us, what we see is we have some angle that makes cosine turn into -2 divided by 3. Well, what that means for us is whatever this angle is, when we plug that angle into cosine, it makes cosine equal -2/3. And right here, we can use this information to extract the adjacent and furthermore to extract the hypotenuse from cosine inverse. One quick note is that if there's a negative sign, that never goes with the hypotenuse. The negative is always going to go with either the opposite or the adjacent. Now, what we can do is just draw a circle. On the circle, we can make -2 our adjacent, and we'll just draw, a little bit steeper. We'll draw a hypotenuse, that's 3, drop a side straight down to the x-axis. Now we have a triangle, and this triangle, on the inside, we can put theta as our angle. And I'll just scoot this -2 over now so it's a little bit clearer that that's the length of this entire side. We're going over 2 steps in the negative direction. And now we need to follow the order of operations to actually fill in the third side right here, which for now, we'll just call this b. So using the Pythagorean theorem, we have a squared plus b squared equals c squared. The hypotenuse is always c. Now b squared, we don't know what b is, so we'll leave that for now. But a is -2. -2 squared is +4. We still have our b squared. And 3 squared is 9. If we subtract 4 from both sides, goodbye, we have b squared equals 5. And finally, if we take the square root of each side, that cancels the square with the square root. We see that b, even though it's technically plus or minus square root of 5, if you notice, I've drawn this so that b is above the x-axis, so that would make it positive square root of 5. I'll get back to a detail at the a little detail at the end that can tell us exactly where our angle is. But first, we can replace here, we can replace b with square root of 5. Now, I'll go ahead and jump into that detail now. So if you recall, inverse trig functions, just like any other function, has a specific domain and a specific range. And for cosine inverse can only give us angles that are between 0 radians and pi radians. And that's the same as having angles between 0 degrees and 180 degrees. So since cosine inverse can only give us angles as answers that are between 0 degrees and 180 degrees, that means that we're restricted to staying anywhere from 0 all the way around here to 180 degrees. We can only get answers that are in quadrant 1 and quadrant 2. So that would put us in a position where we are simply above the x-axis. That's how we know here, when we get plus or minus, that the y value for this triangle has to be positive square root of 5, because y is positive in quadrant 2. Well, now that we have this triangle, we're done with most of the thinking we need to do. We've figured out the sides of the triangle. We've found all the sides we need to put together cotangent now. So the last step to this is to remember that cotangent theta is equal to 1 over tangent theta. That is also known as the reciprocal of tangent theta. So anytime you take 1 divided by something, it simply takes this thing on the bottom and flips it over, as we'll see in just a moment. So we can say 1 over. Now tangent, going back to SOHCAHTOA, tangent is opposite over adjacent. Sorry, opposite over adjacent. So for tangent on the bottom, the opposite of the angle is square root of 5. The adjacent to the angle is -2. And I'll go ahead and show you what most people are familiar with is change division to multiplication, then flip the second fraction. We'll first write this as division. 1 divided by square root of 5 over -2. We'll keep 1 the same, change division to multiplication, and we'll flip the fraction. And finally, -2 over square root of 5 times 1 is just -2 over square root of 5. And that would be our final answer. Now, one last point. If you're in high school or if you're in college algebra at kind of a more beginning level, it's very common for us to want to rationalize the denominator. That's absolutely fine if you want to rationalize the denominator. I'll post another video where we talk about rationalizing denominators. But for this case, many problems that you see like this will arise in calculus, trigonometry, differential equations, and many things that are past algebra. And in those more advanced classes, we don't tend to focus so much on if the denominator is rationalized or not. So I'm going to leave the final answer as -2 over square root of 5. But just a quick recap. So when you have a function inside of another function, notice there are no variables here. So that means this ultimately is a number. When you're trying to simplify a function being inside another function, you always simplify you simplify from the inside out. For us, we wanted to first just recognize that cosine inverse is an angle. That's what inverse trig functions are. All of these inverse trig functions are angles. So with that in mind, we were able to use our knowledge about cosine being adjacent over hypotenuse to put together a triangle with some angle on the inside. Well, this angle that gives us cosine theta is -2/3, that same angle theta right here, that's the same angle that we want to use inside of cotangent. Well, once we put together the triangle with that angle, then we can use these three sides to put together any trig function we want. In this instance, we want cotangent, so we put together the triangle, and then we go back to our trig identities to see that cotangent is just the reciprocal of tangent. So what that looks like in a formula is 1 divided by tangent. So you can just say 1 divided by, put together tangent in the denominator, and then if you just follow through with some simplifying, you'll take the reciprocal of tangent, and you'll see our final answer is -2 over the square root of 5. So I just wanted to kind of give you a moment to run through another problem like this as an example. So hopefully that helps clarify what inverse trig functions are, how they come in handy as angles, and I hope this just refreshes your memory, if this isn't the first time you've seen this, that often we need to answer trig questions by taking information we know and turning that into a triangle, where afterwards we just take the sides to put together another trig function.